That's when set user ID is 0. When you don't see the S character, when you type ls minus L, you see all the read-write permission access, in front of the file. Sometimes you see the S bit. That means the set user ID is set. If you pay attention. So, yeah, let's look how we can take advantage of this scheme of things. To allow.
Depends on where it's at too. It's also sticky.
Sticky bit, thank you. Yes, I forgot to mention. It's the same thing.
The same thing?
Yeah. Sticky bit is the same thing. Simply. Some people call it the sticky bit. Because it sticks to you, right? The owner sticks to you, right? To allow users to access a network without letting them write their own networking programs. This is what we do. One, set user ID bit to 1 for network programs. Root owns the networking programs. When a user runs a network program, she would run it as root. Right? All the privileges. That's kind of scary, isn't it? But first, those programs have been written and compiled, presumably by the root, somebody that knew what they were doing, right? And second, there's no way around it, right? You need to have root privileges to be able to perform communications, right? Unless, which is the next topic coming up, unless you could somehow get into that program, maybe using buffer overflow and change things while it is running, So you're running a program as root, and somehow while it is running, you change it so that it becomes another process. And then you would have access to do things, right? Buffer overflow does that. Am I making sense? I don't want to lose you here. So yeah, this is a potential security problem. So this is one way of doing it. If a hacker creates a file with set UID equals 1, change owner to root. Unless you're the root yourself. But let's say somehow they did that. And with buffer overflow, that can happen, just like the example that I said there. As soon as the hacker executes the file, he would have root access. Right? Because now this program is running, and it's running as root. And he could do anything within that program. You know, he can program to do anything in that program, right? So let me just show you access matrices, and then we'll expand on this concept a little bit more. This is in chapter 14. So this is the domains that I was talking about here, right? This is figure 14.1. So domains can be overlapping, right? See? So object 4 is overlapped between domain 2 and 3. So domains again can be users or processes and so on, right? Each domain. Other forms of rudimentary protections is Multics. Remember the predecessor to Unix, right? So we had these rings. Remember I talked about this in class before. This is, you know, the type of operating system that was written in the 1960s for Air Force. You know, they wanted to have hierarchy of, access rights. Because that's how the military is set up, right? And this is an example of an access matrix. This is figure 14.3. So you have these domains, D1, D2 through D4, and these objects, F1, F2, F3, and printer. So in domain D1, you have read access to object F1 and read access to F3. In domain 2, you have print access to the printer, right? And so on and so forth. Okay, so this is one way of modeling protection, right? Makes sense? So this is how you model it, and then the implementation could be any which way that the system wants to implement this concept, right? This model. You can expand on this a little bit more to say how to change your domains, okay? So a process could be in domain 1, having read access to F1 and F3, but it can change to domain 2. So you switch to domain 2. So that at some point it could start printing and maybe later on switch to the other domains. So this is called access matrix. You should be exposed to this. And again, the concept is universal, right? But each operating system implements it differently. Okay, so go to chapter 15. Let's see. That's on security.
Chapter 14 will be on time, or?
Yes, the things that we talked about again. We just. So let's let me just discuss some of the things under the security concept. Again, that you need to be exposed to. So yeah, some people ask me about changing file systems to advanced operating systems. Yeah, that is going to happen, but potentially not next year, but the year after that. So in that advanced operating system, we're going to cover file systems, I/O, and protection and security. Because as you noticed, we really pushed it, and we ran out of time for these concepts. There isn't not enough time. There isn't enough time. Chapter 15, security. So another definition is protection. Another definition for security is protection from external threat. Right? You should always associate security with external threat and protection with internal threat. Right? So examples of this are just unauthorized access. Just that is really bad, right? Even not doing anything bad, just a user getting on your system and just looking around. That really makes me mad. If somebody does that to my computer, not doing anything bad. Of course, it would be even worse if it is malicious distraction. And then worse than that, in my mind, would be introduction of inconsistencies. So your system starts doing unpredictable stuff, So let's jump to section 15.2, program threats. Because I know you've seen these things, so let's kind of define them. Trojan horse. This is a program that misuses its environment. These programs do not replicate. But masquerade